All right, we're in Calc AB Notes something. Notes 2, talking about page 4. We're doing the chain rule. And this is a really interesting question, I think. It says, if f of x is the quantity 4x squared plus 3x to the fifth, and g of x is 4x minus 5, find the derivative of f of g of x at x equals 1. Do this problem without performing the composition. So what you could do is you could take g of x and just sub it into f of x. It's going to look hideous. But then you can find the derivative of that. Potentially, you'll probably make a mistake because there's like a lot of nesting going on there. But it says that we can do it without that. So I'm going to think of this. I'm going to say, a thing you do in calculus a lot to make your life easier is you just like define a new function. I'm going to say let h of x equal f of g of x. Okay, so what I'm really finding is h prime of 1. So h prime of x, according to this, h prime of x should be the derivative of f of something is f prime of that thing times the derivative of that thing. Okay, so what does that mean? Well, it means that h prime of 1 is going to be f prime of g of 1 times g prime of 1. Okay, well, g of x is this thing. So I can actually just find g of 1 and g prime of 1. So g of 1 is definitely 4 minus 5, so negative 1. And g prime of x is 4, so g prime of 1 is 4, right? G prime is actually equal to 4 no matter what x is. So now what I'm trying to do is I'm really trying to find, so h prime of 1 is f prime of g of 1 we found was negative 1 times 4. All right, well, now I need to find f prime of negative 1. To do that, I'm going to need f prime of x. So f prime of x is, bring the 5 down, 4x squared plus 3x to the fourth times the derivative, which is 8x plus 3. Okay, so f prime of negative 1 is 5. You get 4 minus 3 is, well, that's convenient, is 1 to the fourth. And then negative 8 plus 3 is negative 5, so you actually get negative 25. So this is negative 25 times 4. I think you get negative 100. So I think my final answer here is negative 100, and I never did the composition. It's crazy how the chain rule will let you get around things like that. Just makes your life a lot easier. Like if you know what you're doing with the chain rule, your life will be so much easier. So make sure you do. Just make sure you understand it. And it's not hard. It just takes a little practice, but things that take practice are great, right? Because it just means that practice is all that stands between you and being good at them. So let's see this. The graphs of f and g are shown below. And I just want to hold on. I got to look at this on my other computer so I can see, how much we have to go on this page and should we keep going. All right, we're going to do maybe one or two of these. So the graphs of f and g are shown below. Use them to find the derivative of each function at the given value. If memory serves, some of these might not exist, and that's okay, because not every function is differentiable at every point. Differentiable means the derivative exists, and so it's possible that some of these will not be differentiable. So let's start off. All right, so I'm going to find the derivative of this thing. It doesn't have a name, but I'm just going to dive in and say that it's f prime of g of x, g prime of x. And then maybe I'll do such that x equals negative 3. I don't really like that. So what I'm probably going to do next time is name the function h of x or whatever. So I'm going to find f prime of g of negative 3. And then I will multiply that by g prime of negative 3. So like that's my goal. All right, so now I got to find g of negative 3 so that I can sub it in, right? So I'm looking for g of negative 3, and then maybe simultaneously I need to know what g prime of negative 3 is going to be. So g of negative 3. So we go over to the graph of g. Negative 3 is like here. So that's going to be 1.5, which is kind of an estimate, but also definitely accurate because the slope here is like down 3 and then over 2. So if you started at 3 and you move over 1, you'll go down 3 halves. You go over, you'll go down 1.5. So you're going to get 1.5. So I did kind of estimate it, but it also was true. So that, and then, oh, actually I needed that slope too. So that's silly. So this was, you're going down 3, you're going over 2. So the slope there is just the slope of the line. So g prime of -3 is definitely -3 halves. G of -3 is 1.5. So we're doing f prime of 1.5 times -3 halves. Okay. Now I need f prime of 1.5. So 1.5 is maybe like here. And we're in luck because it's on a line segment, right? So I just need the slope of this, which is down 2 over 3. That's kind of interesting. So I get -2/3 times -3 halves, which is 1. So I think that the slope of f of g of x at x equals -3 is 1. I don't know. Wasn't anticipating that, but that's totally fine. All right, let's say, I'm going to say h of x is g of f of, so this will be the last one I do in this video. So h prime of x is, the derivative of g of something is g prime of that thing times the derivative of that thing. That thing is f of something. The derivative of f of something is f prime of that thing times the derivative of that thing. That thing is 2x. The derivative of 2x is 2. All right, so h prime of 2.5 is going to be g prime of, so f of 2 times 2.5 is 5 times f prime of 5, and then times 2. All right, so we got to start with f of 5. F of 5 is definitely -1. So we're going to try to find g prime of -1, and then we'll multiply that by f prime of 5 and 2. So f prime of 5 we can find because it's the slope of this line, which is -2. So -2 times 2. Now we gotta try to find g prime of -1, but I kind of just peeked up there. So this is the graph of g of x. So at -1, we have a sharp turn, which means that g prime of -1 does not exist, which means I'm going to say h prime of 2.5 does not exist because g prime of -1 does not exist. And then I don't think I really want to explain. Well, I'll say because g of x has a corner or a sharp turn. Because g of x has sharp turn or corner at x equals -1. So there's one. It didn't exist. The problem with it not exist, not a problem, but the annoying thing is that you got to do a lot of work before you even see that it doesn't exist. So I mean, you could be constantly like head on a swivel, surveying your graphs as you go. I mean, that's an option. I think it's better to just like let it play out, and then at the end you're just like, oh, it didn't exist. All right, I'm gonna stop this here. Come back in the next one. Do more of this. Probably finish the page. Who really knows? See you there.